Okay, this is 1997 question 2, and the reason we do this one is it's one of the more challenging problems that has come up on the AP exam, and this one covers blocking, and it's just hard for people to get their head wrapped around it, but once we do it once, you're able to apply it to a lot of other questions. So please pay attention to this one. A new type of fish food has become available for salmon raised on fish farms. Your task is to design an experiment to compare the weight gain of salmon raised over a 6-month period. So we have new fish food that we want to know how it's doing. We're going to compare weight gain. Weight gain is probably our response variable. The salmon you will use for this experiment have already been randomly placed in 8 large tanks. We look down here and we have 8 tanks. And that has a considerable temperature gradient. And so what they're saying is different parts of the room are different. Specifically, tanks on the north side of the room tend to be much colder than those on the south side. The arrangement of the tanks are shown in the diagram below. So while it's not labeled, this is the north, and this is the south. Describe a design for the experiment on weight gain that takes into account this temperature gradient. So in other words, how can I control for how the impacts the temperature gradient? Well, what's going to impact this? Now, this doesn't label this very well, but this is a window. This is also a window. Okay, so I need to be able to, let's think about what's impacting things for the heat. We have a heater that's impacting it, we have a door that's impacting it, and we have a window that's impacting things. So let's talk about those things. Let's write them down so that the reader knows we know something. The sources of heat gain or loss are the windows, the door, the heater, and the north and south sides of the room. So I would need to block so that each tank in the block would be equidistant from the source of heat gain. Remember, in a block, you want the blocks to be as similar as possible. So when I look at this, it's like, well, where would be the easiest point to start at? And I go, you know what? 6 and 7 are exactly the same distance from the heater. So that should probably be a block. It doesn't matter whether you call it A, B, C, or D. And it was like, oh, okay, yeah, those are closest to the heater. Those should be about the same. And these two are the same distance from the door. So that would make a good block. Okay, so we have these 2 blocks. We have what I call block 2 and 3 and 6 and 7. Those look about the same. But now I have these others left. Well, when I look at this one, it's close to the window, and this is close to the window. So 1 and 4 are about equal distance from the window. They're also about equal distance to the heater, and they're also equal distance to the door. So 1 and 4 are very, very similar, and that this distance and this distance, this distance and this distance, and then this third distance are about the same. So 1 and 4, that looks pretty good. And then 5 and 8 are about the same distance to the heater as each other. They're also about the same distance from the window, and they're also about the same distance from the door. So that's the way I would block them together. All right. So these blocks are most similar in regards to heat gain or loss. So now they said describe a design. So I chose how I was going to make my blocks, but now I need to design it. For each block pair, I would flip a coin to assign the fish food. If the coin showed heads, then the tank with the smaller number would receive the new fish food. Now, could I just put the 2, could I put 1 and 4 in a hat and draw, and whichever I draw gets the new fish food and the other one gets the old? Certainly, that would be fine. If the coin shows head, then the tank with a smaller number receives the new fish food, and the tank with a larger number receives the old fish food. I just used a coin because we hadn't done that before. If the coin shows tails, then I would assign the older fish food to the smaller number tank in the block and the new fish food to the larger. So that explains how I would use a coin. Probably easier just to put 1 and 4 in a hat, and the one that I draw gets the new, the other one gets the old. After appropriate amount of time, I would compare the average weight gain. There's my response variable. So I explained my blocks, how I'd put them in the blocks and why I would put them there. Then I randomly assigned the treatments, how I was going to assign the treatments, the new fish food and the old fish food, described the assignment. And then I talked about the response variable. Okay. And once again, when you're blocking, you block so that within the block, they're as similar as possible. 2 and 3 are the most similar because they're equidistant from the door, equidistant from a window, equidistant from the heater. All right. And remember, both treatments are assigned in a block. So treatment 2 got either the new or old fish food, and block 3, and this one would have gotten the other fish food. Okay. Also, remember, blocking only applies to experiments. It does not apply to surveys and observational studies. Stratification applies to surveys and observational studies. With blocking, you want to be as similar as possible, and 2 and 3 are the most similar, and 6 and 7 are most similar. So blocking is for experiments, stratification is for surveys. Sliding this up so that you can finish writing. And thank you for watching this video.